Hello everyone, my name is Meetpal Singh and from class CPR 101 ZCC, and today I'm going to present the topic of quantum computing. So let us begin, shall we? So, what are the quantum computers? How do they work? Why do we need them? What are their possible applications? Classical computers represent data in the form of bits. Bits can either be 0 or 1. These values can be derived by passing electrons through transistors made up of semiconductors present in any computing device. Think of transistors as a small button. Pushing the button allows the electron to flow through the transistor, outputting the value 1. Whereas if no electron passed through the transistor, the value assigned is 0. Over the past decades, the number of transistors has increased and become denser to generate more computing power and less heat. But as the size of the transistor is reaching near that of an atom, the phenomenon of quantum tunneling makes the electron pass through the transistor even if the switch is off, resulting in the wrong data being computed. This poses the problem to the future of computing. Here comes the quantum computers, which utilize the phenomenon of superposition and entanglement to derive qubits. Qubits can be an electron whose magnetic spin or a photon whose polarization is measured. In the quantum realm, qubits can exist in both 0 and 1 state. By superposition, we can calculate one of its state, and by entanglement, we can calculate its other states. This is a game changer, as a pair of bits can have 2 bits of information, whereas a pair of qubits can have 16 bits of information. Therefore, a group of qubits can calculate 2 to the power n times more information than n number of bits. This decreases the time required for the computer to process a particular amount of data. That is why the applications of a quantum computer can foster research and development at a much faster rate. Although with such groundbreaking computing power, many companies are unwilling to invest in them as they still find the classic computers enough to handle their workloads and cheaper to run. Also, the running cost of these computers is very heavy on the pocket as they need to operate in the temperature near to the absolute zero. Plus, a $15 million price tag further dissuades the investment in these computers. There are companies like IBM and D-Wave which are continuing the development of quantum computers and provide open cloud access to the world so that people can develop and research on quantum computers even if they don't have one. Also, it is believed that in the oncoming years, quantum computers will become smaller and cheaper to run. The shift to the quantum computing will be slow but gradual. Elon Musk, the CEO of Tesla, recently introduced their own quantum computer, which will be used to train Tesla's autopilot and full self-driving AI, which was difficult to train earlier because training it required a lot of cloud computing power. These computers can also be used for oil and gas exploration, space exploration, climate modeling, financial modeling, 3D modeling, weather forecasting, consumer product design, digital security, and also nuclear test simulation. Will quantum computer reach average consumer? Even if these computers are feasible to an average person, these are not beneficial for them as they will not experience any difference. Instead, their quantum computers would be slower than a regular computer to do a basic task like watching a video or playing video games. Still, the fact cannot be denied that quantum computers are still at an infancy stage, and yes, they are the future. But having one of these in a regular desktop is still many decades away. But it is also estimated that many companies and organizations will transit to quantum computers before 2050s. And that is all for today. Thank you for watching and have a nice day.